Welcome to another lesson in the Designing VMware Infrastructure training course. The title of this lesson is Determining vSphere Design Factors. In this lesson, we'll start out by discussing determining the design factors. We'll quickly review the 4 design factors that shape every design, and then talk about the process for determining those design factors before you move into the rest of the design process. That process for determining the design factors is comprised of gathering information for requirements, something we'll discuss in great detail, defining the requirements, and then using those requirements to identify your risks, constraints, and assumptions. Before we get into the core of the lesson, let's first start out with some key terms that you need to know. Recovery Time Objective, or RTO, is a measure of the time required to recover an environment, typically in the event of a disaster or other qualifying event. This would be measured most commonly in hours or days, so it wouldn't be uncommon to say that we have a 1-day RTO or a 2-day RTO. The shorter the RTO, the faster the services are returned, and typically the more difficult or more involved that recovery will become. Related to RTO, but slightly different, is Recovery Point Objective. Now, both of these are used to define how a service responds in the event of a disaster or the qualifying event. RTO says this is how quickly we will get the service back up and running. RPO says this is how much data loss, if any, I'm allowed to sustain. And this would typically be an indicator of how often data is replicated or how often data is backed up. If you back up your data once a day, then you have an RPO of 24 hours. If you were to replicate your data via some sort of array-based mechanism or something of that nature, and you replicate that data every 4 hours, then your RPO is 4 hours. If you replicate every 8 hours, your RPO is 8 hours, so on and so forth. These two together define how quickly and how resilient a service is in the event of a qualifying disaster or other situation. Again, a shorter RPO means that there is less data loss, and therefore it's more complicated or more expensive to make sure data is getting replicated or backed up more frequently. A shorter RTO means that you have to be able to recover very, very quickly. Longer RTOs and longer RPOs mean that the service or application can sustain more data loss and can be down for a greater period of time. Typically, very, very important applications will have shorter RPOs and RTOs. Less important applications will have larger RPOs and RTOs. An SLA, or a service level agreement, is some sort of quantifiable agreement between an IT department and the business units, and it defines a particular service or application and describes the availability, performance, RPO, RTO, resiliency, fault tolerance of that particular service. Now, you'll use this as the architect in helping to define what sort of services are in here and how those services should be treated, and then you'll use that when determining your requirements and your risks and consumptions and constraints to make sure that the design is capable of providing services that would satisfy the service level agreement. Related to a service level agreement is a service level objective, or an SLO. This is not necessarily an agreement between IT and business units, but more of a statement. This is what IT is shooting to provide. This is our objective or our goal for the kind of service level that we'll be providing for this particular service or application, so it is related to SLA. Now, with those definitions in our toolbox, let's move forward with a discussion of determining the design factors. Recall from another lesson in the course that there are 4 design factors that influence your design. These 4 design factors: requirements, risks, assumptions, and constraints, each influence the design in a different way, and they will shape the design throughout the entire design process. Before you actually begin any sort of writing of documents or creating of diagrams or anything else of that nature, you first have to gather the information necessary and identify and define or determine these design factors. This is indeed the first step in the design process, and it has to occur before any other work does occur. This process can be described by the workflow that you see on your screen now. The steps here kind of break down how you go about determining the design factors. You'll first start by gathering information from various sources. I'll talk in a moment about what sort of information you're going to gather, the sources that you're going to get that information from, and what type of information you need to get. You'll then use that information to define your requirements. Once the requirements are defined, and once you understand what design has to do based on those requirements, you can then perform a requirement analysis to determine your risks, constraints, and assumptions. Once you've got all 4 design factors finalized, your requirements, your risks, your constraints, and your assumptions, you then need to get sign-off from the project team. If the project team approves of the way you've defined the design factors, then you're able to proceed with the logical design. Logical design is a topic that we'll discuss in greater detail in another lesson in this course. If the project team doesn't approve of the design factors, then you'll have to iterate through this process again. You have to go back and gather additional information, analyze that information to define the requirements, and then analyze those requirements to see if there are risks, constraints, or assumptions that are either incorrect the first time or that you missed the first time. And you'll continue through this process until the project team does say, yes, we're ready for you to proceed with a logical design. Now, it is important to understand, though, that even though you may get the sign-off from the project team to proceed with logical design, this process of gathering information and defining requirements will continue throughout the design process. And there are other stages in the design process where you're going to have to reevaluate some of your design factors. Notably, in another lesson in this course, we're going to talk about where we map the logical design onto a physical design. And at that point, we may encounter additional design factors, additional constraints, for example. So this process does occur primarily in the early part of the design process, but it will also occur throughout the design process, not just in the beginning, but continually throughout the design process. The first step for determining your design factors is to first gather information for requirements. The information for your requirements is going to come from many different sources. Here on the screen is a partial list of some of the sources where you can gather information about requirements. You might gather information for requirements from the lines of business. The lines of business could provide information like projected growth requirements, RPO, RTO, SLA or SLO, performance expectations, which would typically be wrapped up in your SLA or SLO. You might also gather information about requirements from the application owners. The application owners may give you information about what sort of requirements the applications have, what sort of resources they need, how they are expected to perform, what dependencies exist. Your IT stakeholders, such as the IT director, CIO, CTO. Operational teams that are responsible for managing or operating the environment. If this particular design is also slated to take care or be related to a particular project, you may find information found in the project charter or other existing documentation. All of these can be different sources for information for the requirements. How do we go about getting this information out? Well, extracting the information can happen in a variety of ways. It would not at all be uncommon to have meetings and interviews with some of the people that I identified previously. So you may have meetings with the IT stakeholders, you may have meetings with the operational teams, you may have meetings with the project managers or project stakeholders, you may have meetings with those individuals inside the lines of business, all with the intent of gathering information to understand what sort of requirements this design has to fulfill. You might also have to review existing documentation, so documentation about the environment as it exists, documentation about projects that they intend to fulfill with this particular implementation, documentation about existing SLAs or SLOs, RPOs, RTOs, information about existing processes, procedures, responsibilities, ownership. All of that could come out of existing documentation. It will also be critically important that you perform, if it has not already been performed, an assessment of the current environment. I'll talk in more detail about how we can go about assessing the current environment in just a moment, but this will give you a critical insight into what the environment looks like currently and how you can take that current environment and help move them forward towards the desired end state in your vSphere design. As I mentioned, it will be important to gather information about the current environment. There's a number of different tools that you can use here. For example, you could use VMware Capacity Planner. This is a hosted service provided by VMware that allows you to assess existing systems, gather information about performance utilization, inventory, hardware, all of that, and then create a set of recommendations around which applications can be virtualized, which applications should not be virtualized, or simply resource requirements, how many CPU cycles you need, how many gigabytes of RAM you need, how many terabytes of storage you need, how many megabits or gigabits of network throughput you need. You can also supplement that information with OS-specific tools, such as Performance Monitor in Windows or equivalents inside Linux and other Unix operating systems. Existing server, network, and storage, monitoring, and management applications are also a great source of information. They can give you insight into the current server base, what sort of problems they may be having, what sort of the current configuration might be. Network tools can give you information about network throughput, traffic flows, dependencies. Storage monitoring and management suites can give you visibility into how the storage is being utilized and what applications and other tools are actually using it. If they are already virtualized or if they are preparing to virtualize, Some third-party virtualization assessment or third-party virtualization management products might be useful. For example, in the third-party virtualization assessment area, there are tools like PlateSpin Power Recon or Serba that also do the same thing as Capacity Planner and may provide you additional information about the environment and what it looks like. For environments that are already virtualized and perhaps migrating to a new environment or to a new version of vSphere, then existing virtualization management products like vCenter Server, vCenter Operations, Capacity IQ, or similar third-party products can help give you insight and information about the current environment and what it looks like. All of this information is critically important and will play a vital role in how you size the design to make sure that you meet existing requirements and plan for growth if that is a requirement of the design. While you want to be as thorough as possible in gathering information, you also want to make sure that you don't try to boil the ocean. That phrase simply means you want to stay in scope. You don't want to try and do all things and be all things to all people in the organization. More than likely, this particular design has a very specific purpose. It has a project charter backing it. You want to make sure that you stay in scope and don't allow yourself to try to expand the scope of the project. Key points of information you'll want to gather. We've mentioned some of these already. RPO, RTO, SLA or SLO for each application or service. Any application dependencies, what other applications or services does this application depend on, or what other applications or services are dependent upon this application? What sort of resource needs are there? How much RAM, CPU, storage, network do the various applications and services require? Are there cyclical periods where resource utilization increases, or are there periods when resource utilization is very, very low? What are the performance expectations? Some of this information may be wrapped up inside the SLA or SLO, but it's important to understand what does the business expect in terms of performance. You'll want to gather information on operational factors. Who performs what tasks? Which group owns certain tasks? This will play a role in determining how the design functions. And as I mentioned already, you're going to want to gather plenty of information about the current environment and the product or solutions that are in place before this design implementation takes place. Once you've gathered all this information, once you have talked to the lines of business, you've reviewed documentation, you've assessed the current environment, you've gathered all of the details that we've discussed so far, then you're ready to actually sit down and try and define the requirements for this design. As you go through this process, let me provide a few guidelines that might help. First, you're going to want to use language that is simple and easily understood. You don't need to make this overly complicated. Just state the design requirement, what it needs to do, and make sure it's understandable. Be clear and specific, not vague or ambiguous. You want to make sure that it's clear what this requirement says. Don't leave any questions out. If there are questions, you're going to address those with an assumption, as we'll see in just a moment. And try and define your requirements individually or separately. Don't combine them. Make sure that each requirement is individually listed. As I mentioned earlier when we described the process for determining the design factors, these sets of requirements might change as the design progresses. Let's take a look at an example requirement that's been defined and then see if there's some way we can improve this sample requirement. So here's a requirement that's been gathered. It says the design should be resilient and highly available. Well, this is fairly obvious. Few customers are going to want to build a design that is not resilient or not highly available, although it certainly could be a possibility in the right environment. But the main problem with this requirement is that it's vague. What do we mean resilient? What does resilient mean? And what is highly available? There are lots of different ways to make sure that a design is highly available. And different customers, different organizations have different views of what that term highly available means. Therefore, it's important that we be as specific and clear as possible. For example, perhaps it would be better to take this vague example requirement and reword it in this way. Wherever possible, the design should not possess any single points of failure. Here, the requirement is very clear, it's very understandable, and it's very specific. We're saying the design should not possess any single points of failure wherever possible. Now, naturally, that will translate into a design that is resilient. It will translate into a design that is highly available, but we've been very specific in how we achieve those goals. Now let's take a look at a couple more examples. This example requirement was taken from the Cloud Infrastructure Architecture case study that I reviewed with you in another lesson in this course. It says a separate management VLAN must be used for management traffic. Again, very clear, very concise, and very specific. It says we're going to use a separate VLAN for management traffic. If they had been vague, they would have just said management traffic must be separated from other types of traffic. But here we said we're going to use a separate VLAN for management traffic. It's very specific and very particular. And this is the way you want to look at your requirements. Make them very specific, very clear, and very concise. As you go about defining the requirements based on the information that you've gathered from the various sources, you're going to want to separate your functional requirements from your non-functional requirements. You still have to satisfy both the functional and non-functional requirements, but the impact of the functional requirements and the non-functional requirements is different. The way that these affect the design, the way that these shape the design are different. Now, why would you want to separate them? Non-functional requirements can sometimes be modified based on the findings of your requirement analysis, meaning that when the company gives you a non-functional requirement, for example, we'll take a non-functional requirement from an earlier lesson in the course and we'll say that they specify a particular vendor you have to use. After you do your requirements analysis, you may find that using that particular vendor may present a risk to the design. I'm going to walk through an example of this in a moment. So you may find that it's necessary to modify non-functional requirements. Functional requirements, on the other hand, typically are not going to be something you can modify. The design has to do what the design has to do. It has to fulfill the functional requirements, and therefore, these are typically not going to be something you can modify. There have been and will be cases where they can be modified. As you go through the design process and you bring these back to the project team, they may say, no, that functional requirement needs to be modified. But typically, if you've gathered your information and you've been as thorough as possible and talked to the right groups, you will have a good feel what the functional requirement is going to look like. Now let's take a look at an example and see if we can identify, is this a functional requirement or is this a non-functional requirement? The requirement says, the design must accommodate the migration of physical systems into the virtualized environment without changing IP addresses. My question to you, is this a functional requirement or is this a non-functional requirement? If you said functional requirement, I agree with you. Here we're saying this is something the design has to do. The design has to accommodate the ability to migrate physical systems into the virtualized environment without changing its IP addresses. A non-functional requirement would have said how we go about doing something. We would have said the design will use network address translation to maintain IP addresses or something similar. But we're not specifying how we go about doing it. We're just specifying what needs to be done. The function that needs to be represented in the design is the ability to migrate physical systems without changing their IP addresses. So this is a functional requirement. Once you've gone through the process of defining all of your requirements, so you've gathered all the information from all the various sources, you've assessed the current environment, you've interviewed current administrators and architects, you've talked with the stakeholders, you've gathered all that information, you've gone through and reviewed all that information to create your requirements. You can then use those requirements and perform a requirements analysis to determine your risks, constraints, and assumptions. By separating out your non-functional requirements, these become your constraints because they constrain the options that you have in satisfying the functional requirements. You take the non-functional requirements or your constraints and your functional requirements, and then you compare those and analyze those to see if they present any risks. You might also identify any other risks that are evident from the information that you've gathered. And then where information wasn't able to supply a requirement or a framework in which you can operate, then you might need to define something to say this is how the design is going to operate. You would define that using an assumption. As you go about identifying risks, you're going to want to provide suggestions for minimizing or mitigating risks, which will then lead possibly to changes to requirements or constraints, and that will in turn lead you to go back through the process again. Again, referring to that cyclical process where we have to go through these steps until everything has settled out and we have approval. You don't want to proceed with logical design until you've gotten sign-off from the project team on the design factors. As I mentioned earlier in this lesson, those design factors may be altered as you proceed throughout the course, but you want to make sure that based on the information that's available to you right now, everybody is in agreement on the design factors and how they're determined and defined. Let's take a look at a few examples of some requirements and constraints and how we might analyze those to determine a risk. This constraint was taken again from the cloud infrastructure architecture case study that I shared with you in another lesson in this course. It simply says that NetApp's NAS offering has been pre-selected as the storage solution of choice. So here this is a non-functional requirement. It's a constraint. It says that we're going to use this particular vendor, we're going to use NetApp, and we're going to use NAS or NFS to be the storage solution for this particular design. In and of itself, a constraint doesn't really help you. It's simply a constraint. It's simply a non-functional requirement. It doesn't necessarily point you to any other information. What you have to do is look at all of these pieces of information in a holistic approach, again, looking at all these things as inextricably interrelated, and then determine where these different areas possibly conflict. If we take this constraint in the light of the following functional requirement, then we can begin to see something. Suppose that in addition to the previous constraint, we also determined this functional requirement as coming out of the information that we gathered from the organization. The functional requirement states that the environment must be capable of supporting virtualized instances of Microsoft Exchange Server 2010. Again, in and of itself, this functional requirement doesn't tell us anything, not as far as risks or assumptions go. It does sort of drive certain things. You know that, okay, this is going to be supporting Exchange Server 2010, so immediately certain things are going to have to happen in the design. Particular to this example, we know that Microsoft Exchange only supports block level protocols and not NAS protocols when running in a VMware vSphere environment. So take in conjunction with the previous constraint, then this functional requirement now creates a risk. The risk that results from the requirements analysis, where we took the existing non-functional requirements and the functional requirements and all the information provided to us, and we analyze that to determine if there are issues. The risk now is that the pre-selected storage solution is not supported for use with applications specified in the functional requirements. We've said that if we follow this constraint, saying that we have to use NAS, and we know that we have to be able to support Microsoft Exchange Server 2010 in the environment, we have a risk, we have a gap, we have a conflict. We have to resolve that conflict somehow. So we have to go back and modify either the non-functional requirement, the constraint, or the functional requirement. Now, which of those do you think the organization is going to be more willing to modify? Are they going to be willing to change their email platform? Possibly, not likely. Instead, they're going to need to say, maybe we can't stick with NAS as our protocol of choice. So you can present a modified constraint back to the organization when you take this to the project team. Here's an example. You could go back to the project team and say that instead of pre-selecting a NAS solution, we can simply say that the particular vendor will be the storage solution of choice. This gives us the flexibility to say that some applications might need to run across block because of support statements or performance concerns. Some applications might be fine to run across NAS because we want to save costs or because we are more comfortable with that solution and have more knowledge and more experience in it. But what we've done is we've taken the information that we have, we've taken a constraint or a non-functional requirement, we've compared that with one or more functional requirements, we've identified risks or gaps where these don't jive with each other, and then we've modified that information to present it back to the project team to get their approval so that we can proceed with logical design. Here's a view of this process again. We've discussed how we gather information from the various sources, the types of information we need to gather, the sources where we might get that information, the processes whereby we might extract that information. We then use all that information to define the requirements, which would be both functional and non-functional requirements. We can then analyze those requirements to determine our risks, identify our constraints, create assumptions where necessary, where information is missing or incomplete. We can fill that in with assumptions. As I showed you in the example just a moment ago, you can then compare all this information to identify risks, potentially push changes back into non-functional requirements or constraints, and then take that to the project team. If the project team approves, then you can proceed with logical design, which we'll discuss in another lesson in this course. If they don't, then we have to go back through that process again. We have to go back and extract additional information if necessary, talk to additional business units or additional application owners or additional IT stakeholders, define the requirements once again, and perform another requirements analysis to determine if the risks have been mitigated or minimized. Our constraints might be different, and we might no longer need assumptions, or we might need additional assumptions to fill in gaps in information. And once the project team gives their sign-off, as I mentioned earlier, then you're ready to proceed with logical design, and you're able to take these requirements, these design factors, and map them against the logical design as the next step in the overall design process. In this lesson, we talked about determining the design factors. What are the design factors again? How do we go about determining the design factors? We then discussed how to go about gathering information to determine our requirements. Requirements become the piece that we use to help determine all the rest of the design factors. Then I provided some guidelines and suggestions for defining requirements, some things to avoid, some things to do. And then we discussed how we go about performing a requirements analysis to then take the information that we use to create our requirements and identify risks, constraints, and assumptions, getting sign-off on the design factors from the project team, and then being able to proceed with logical design. We'll discuss logical design in another lesson in this course. For now, that's it here. Thanks for watching.